Okay, so today we're going to take a little bit of time to look at some of the math that corresponds with this chapter in more detail. Last time we spoke about some basic vocabulary, including these words right here, period and frequency. So I wanted to revisit these first. Period, once again, is a measure of time. So it's a capital T for time, and it's going to give us the number of seconds that it takes for one complete wave oscillation to occur. Okay, so our unit here is seconds. Frequency is going to be indicated with a lowercase f in our formula, and this is going to tell us how frequent or how often our wave occurs within a 1 second time limit. And if we look at our units here, the units for frequency are a new unit. It's a new unit for us, and it's called hertz. So let's take a second and let's look at what hertz means. Down here in gray, I have kind of a formula in itself that's showing how the units for our hertz come to be. So we can see here that we have 1 over seconds right here. 1 over seconds is what I said is the equivalent of a hertz. And if we look at our definition, this is the number of waves, or the number of oscillations, or the number of cycles per second. So this top number, we're just counting how many waves take place. That's not actually a unit of measurement, the wave itself. So when we simplify our units for our math work, we see that we'll have some number on the top and then seconds on the bottom. So whenever we go to simplify our units here, it indeed simplifies to only having seconds in the denominator. So it would be an implied 1 in the numerator. And that is what we mean whenever we say that we have 1 or 2 or 3 hertz. So that's what hertz means. Hopefully that will be helpful for you whenever it's time for you to interpret some of the written questions and determining whether we have given you the period, which is the amount of time for one oscillation, or whether we have given you the frequency, which is telling you how many waves took place during a 1 second time limit. Okay? All right. So let's look at a couple of facts right off the bat. You can see that we have some statements highlighted in these gray boxes. Frequency and wavelength are inversely related to each other. So if we look at the value for frequency and we look at the value for wavelength, as one of those increases, the other decreases. So I have some graphs here that we're going to look at just real quickly to see that inverse relationship. So on this first graph, we are going to assume that all these graphs are 1 second of time. So in this first graph, if I have one wave, and that one wave takes 1 second of time, then my frequency is 1, the number of waves per second. And if we look at our wavelength, remember the wavelength is how far it is for one complete wave cycle. So here we have measured the wavelength for you, and we can see visually, even though I don't have a value here, that that's a long wavelength by comparison to the other illustrations. In this next picture to the right, we have a frequency of 2 hertz because we now have 2 waves that are in our illustration. So here would be 1 wave, and then here would be 2 waves, right? So there's our frequency of 2 hertz. And if we look at our wavelength, you see the wave is now only half as long compared to the wave to the left. And as we continue to look at these illustrations, we can indeed see that the more waves we fit in our picture, the greater our frequency. If these are all 1 second time intervals, then the greater the frequency, the smaller the wavelength. So they are inversely related. Over here, I have kind of a fun fact that I do need you to know. Does the amplitude of the wave affect the wavelength or the frequency? No, it does not. Remember, the amplitude just tells us the intensity of the energy of that wave. That does not dictate the frequency or the wavelength of the wave itself. Okay? And then the last thing on this slide that we need to address is the relationship between period and frequency. Period and frequency are inversely related. So going back to these vocabulary words here, period and frequency are inversely related. Okay? So here are the formulas for this chapter. Frequency is equal to 1 over T. For some of my visual learners out there, it might be more helpful to see it written out. Whoops. So that it has a clear numerator and a clear denominator. So that may be more helpful. Guys, please be careful, by the way. This is the number 1 in the numerator, not an L, okay? And then here we have period is equal to 1 over frequency. Yes, they are the same variables, just rearranged to solve for each other. They are inversely related, okay? And then our last formula here is how we calculate the speed of the wave. That is going to be found by taking our frequency multiplied by the wavelength. Remember, frequency is measured in hertz. Wavelength is a distance measured in meters. And this is actually going to simplify to give us meters per second. Again, if we remember that a hertz is the same as 1 over seconds. So if we multiply this out, that's implied to be over the number 1. We would indeed get meters over seconds, okay? All right, so we have a couple of math questions that I just want to walk through with you really quickly. If the frequency of a wave is 2.0 hertz, what is the period of the wave? So again, we want to make sure that we're taking time to identify all of our givens here. We still want to follow the guess process. So the frequency is 2 hertz. It is asking for the period, so T equals question mark is what they want to know. And this is all that they gave us, okay? So remember, the thought process should be that you go to your list of equations, you find all of the formulas that have the variable that you're looking for, and hopefully one of those formulas you have all of the pieces that are required. So in this case, T equals 1 over F is the formula that we would want to use. We're looking for our period, and this is a number, so that is a set given thing. And this would be the frequency that we identified on our givens. So once we plug in our numbers, this would be 1 over 2.0, sorry about that, which would give us a period of 0.50 seconds. Next question says, what is the speed of a wave with a frequency of 0.75 hertz and a 1.5 meter wavelength? So our givens are F for frequency, and this once again is pronounced lambda for our wavelength, and they are asking us for the speed, so V equals question mark. In this chapter, we only have one formula with the V, so we will need to make our information fit into this formula in the future. If you are given variables that don't fit perfectly, then you need to stop and ask yourself, what is the relationship between what I am given and what I need in order to solve this problem? And then you will have to do the additional math step. Be prepared for us to give you the period and then ask you for the velocity. And in that case, you would have to do this step up here first, where our period would be related to frequency. Of course, if we knew our period and we were looking for our frequency, then we would use this version of the formula. Then once we found our frequency, we could come and plug it in to the wave speed equation, okay? For the example we were given down here in question number 2, it just fits very perfectly into the v equals f lambda. And so we would have a velocity of 1.1 meters per second for this question. All right, just a couple of conceptual things I wanted to review with you while I had a moment. What does a wave transfer? Remember, this was an important fact from our notes the other day. Waves transfer energy. Waves transfer energy, okay? So does it transfer matter? No. Does it transfer energy? Yes, okay? And then down here, I have one more question to go over with you. If a wave has a high frequency, does it have a long or a short period? Remember, frequency and wavelength are inversely related. So a high frequency means we're going to have a low wavelength. High frequency means we're going to have a low wavelength. So short would be the correct answer there. The question number 3 here is actually a math question. It says a sound wave with a speed of 343 meters per second has a wavelength of 2 meters. What is its frequency? So for this question, we would simply solve using our speed of a wave formula. And you can see here that I actually had to do some algebra on that. So V equals F lambda. If I am solving for the frequency, sorry, I kind of jumped ahead and didn't do my list of givens. If I'm solving for my frequency, then I am going to have to divide by the wavelength that they gave me here on both sides. So it would simply be this velocity, 343 meters per second, divided by this wavelength of 2 meters per second. And that's how I got the 171.5 hertz. Okay, make sure that you do your math practice so that you are prepared for the quiz at the end of the week. Have a great day.